Hi, this will be a tutorial on page 188, 6.0, question 9. In that question you had a binomial x plus 1 to the nth power. The exponent is unknown. We don't know how big the expansion will be. The question says the coefficient of the x cubed term is twice the coefficient of the x squared term. Alright, to begin this problem, remind yourself of Pascal's triangle right here. So those are the numbers in Pascal's triangle. Row 0, row 1, row 2, row 3, row 4. So this is row 4, and remember that the numbers were 1, 4, 6, 4, 1, and those are the coefficients of an expanded binomial. So in row 4, the binomial would be a plus b to the 4th power. So if we expand that, I've written it out there, the coefficients, so the first one is 4 choose 0 would be 1, next term 4 choose 1 would be 4, 4 choose 2, 6, 4 choose 3, 4, and 4 choose 4, 1. So again, we have 1, 4, 6, 4, 1. It's symmetrical, 1, 4, 6, 4, 1. The symmetry is important in solving this problem. So notice the second term here in this expansion is the one where the a is to the 3rd power. So that's kind of like what the question's saying here. It says, find the term, or what is going on when x is to the 3rd power, and x is like our a piece and 1 is our b piece, right? So when a is to the 3rd power, we have 4 choose 1. However, looking at this symmetrically, we also have 4 over here, and that's when we have 4 choose 3. Alright, so in other words, if you want to find the coefficient of the a cubed term, you can use 4 choose 1, or you could use 4 choose 3. It produces the same number every time. So 4 choose 1 sorry, 4 choose 1 is the same as 4 choose 3. That will help us solve the problem. So make sure you understand that symmetry there when moving on. So now we know the x cubed term can have a coefficient of 4 choose 3, or in our problem we don't know the power of the binomial, right? If you go back to the beginning, it's a binomial with an n term here. We don't know what the power is. So instead of 4 choose 3, I'm going to write n choose 3. That is what we have in our problem, n choose 3. And now the situation said that in the term where x is cubed, so that's the n choose 3 term, that coefficient is n choose 3, that one is twice the coefficient of the x squared term. So again, this is the coefficient of x cubed term, this is the coefficient of the x squared term, and this one is twice that one. Alright, so that is the key to setting up the problem. If you understand how I got to this statement, the rest is a bunch of algebra, although a little bit tricky, some of the algebra, but that is the key statement. So make sure you think about that for a moment. Alright, so the formulas. This problem can only be solved by thinking of the combination formula. It's not a formula you've seen until a few days ago probably, and you haven't used it much, but it's necessary in this problem. So n choose 3 by the formula is this: n factorial over n minus 3 factorial times 3 factorial. And n choose 2 is n factorial over n minus 2 factorial times 2 factorial. And that has that 2 in front of it here. So I'm creating an equation. Alright, now I'm going to continue this on the next page. So on top, beginning with the same equation I just wrote. Here's the combination, here's the other combination, and this one is twice this one. Now when this expands, if you remember how factorials work, n factorial really means, imagine n factorial is a number. If it said 4 factorial, it would be 4 times 3 times 2 times 1. But n factorial means basically you take the number n, then you multiply it by the next lower number, and the next lower number is n minus 1. Then you multiply by the next lower number again, which is n minus 2. Then you multiply by the next lower number again, which is n minus 3, and so on, until finally you will just multiply by 1. Again, if this was a 4 factorial, it would be 4 times 3 times 2 times 1. So you always get down to 1. So this n times n minus 1 times n minus 2 times n minus 3, it goes on for whatever amount, we don't know because we don't know how big n is, but eventually it gets to 1. Then on the bottom we have n minus 3 factorial. So that's just a number that's 3 less than n, and that number is a factorial, so that number is just going to decrease also. So n minus 3 times the next lower number, which is n minus 4, times the next lower number, n minus 3, and so on, dot, 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 until we get to 1 again. And finally, we have 3 factorial. So that's just 3 times 2 times 1. On the other side, we have that 2, which is here. Then this thing, the n factorial, is broken up just like we did in the first part. N times n minus 1 times n minus 2, and so on and so on. It got cut off here, but it should say dot, 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 1. And on the bottom, we have n minus 2 factorial. So again, n minus 2 times the next lower number, which is n minus 3, and so on until we get to 1. And that's multiplied by 2 factorial, which is just 2 times 1 over here. Things now cancel, and this is really important here. So imagine these going on forever, n minus 3, n minus 4, and so on. They will cancel with all these here, right? Because this is going to be n minus 3, n minus 4, n minus 5, and this is going to be n minus 3, n minus 4, n minus 5. So all those just cancel. And when those cancel, all that remains is the n minus 1, and the n minus 2. Because n minus 3 and onwards canceled away. So here's what all that remains. On the bottom, all that remains after all those cancels is 3 times 2 times 1, which is 6. On the right side, we have the 2. These, again, a bunch of stuff cancels. This was counting down, and n minus 2, and on the bottom, n minus 2, n minus 3. So n minus 2 cancels with n minus 2. N minus 3 cancels with n minus 3. So all these ones after that will cancel. All these will cancel. All we're left with is 2n. N minus 1. Why do I have n minus 1 there? That should have canceled as well. Alright, cross out that n minus 1. It's not going to change the problem much, you'll see. N minus 1 should not be there. 2. So this cancel the 2's. Again, this n minus 1 should be gone, canceled, shouldn't be there. So this shouldn't be there. Alright. Let's see what I have here. Yeah, they cancel. Why did I keep that n minus 1? Oh no, never mind. Let's go back. Yeah, n minus 1 is fine. It's still there. It's that one right there. So n minus 1 is here. That's okay. Anyway, now we're canceling some more. The 2 cancels with the 2. Left with an n. N minus 1 remains. On this side, nothing cancels. But then I multiplied by 6 on both sides to get the 6 over here. Now I have an n minus 1, n minus 1 there. Both cancel. N times n minus 2 equals 6n. Multiply, you get a squared. Move it over. It's a quadratic. N squared minus 8n. Solve it, you get a solution of n equals 8. So few key steps there. Let's recap the key steps. Number 1 was to think about the expansion and notice the symmetry. The symmetry in Pascal's triangle. So over here is the same as over here. So something like 4 choose 1 is the same as 4 choose 3. All right? And that took us to 4 choose 3 being the x cubed coefficient, and that becomes n choose 3. That expanded, and so on. Please watch again. If you're really curious and eager to understand this, you'll probably need to watch a couple times. So do that, do the work, and I think it will come to you. Thank you very much.